In this video, I'm going to show you how to evaluate the behavior of functions at infinity. So we want to write the end behavior shown by all of these functions here. Let's start with the one on the left here. So we want to say f of x approaches something as x approaches infinity. So really, as x gets bigger and bigger and bigger towards the right, what does f of x approach? So looking here on the graph, as x gets bigger and bigger towards the right, f of x is just shooting up, 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 up. It's increasing without bound. So we could just say it's approaching infinity because it keeps getting larger and larger. So let's write that down. F of x approaches infinity as x approaches infinity. Okay, how about this second one? So the second one, g of x approaches what as x approaches infinity? So again, x approaches infinity, going towards the right, x is getting bigger, bigger. What does g of x do? So it looks like g of x is going up, 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 but it's not increasing as quickly as this f of x. Actually, it's kind of leveling off and becoming more horizontal. It looks like there's an upper bound, y equals 3. It's not going above 3, so it's kind of limited in how big it's growing. So as x gets bigger and bigger, g of x is just getting closer and closer to 3. So that's what g of x is approaching then. G of x approaches 3 as x approaches infinity. And y equals 3, we also say that y equals 3 is a horizontal asymptote of g of x, because g of x gets closer and closer and closer to that line as x approaches infinity. Okay, so how about this last function, h of x? So what does h of x approach as x approaches infinity? Well, as x approaches infinity, again, we're going to the right. X is getting bigger, bigger, bigger. H of x now is going down, down, down. And it's kind of like the situation we had before, except h of x is going the opposite way. It's getting more and more negative. It's decreasing without bound. So like before we said, when it was increasing without bound, that goes to infinity. Well, when it's decreasing without bound, that goes to negative infinity. Here's another example. So we want to match each end behavior statement with the appropriate plot. We've got 3 end behavior statements and 3 plots. Each one of these end behavior statements describes one of these plots. So let's just go through them one by one. How about end behavior statement number 1? F of x goes to infinity as x goes to infinity. So what are we looking for here? Well, as x goes to infinity, we want the function to be also going to infinity. So as x is getting bigger and bigger, we want the function to be getting bigger and bigger. So shooting up, up, up. So we want the function to be shooting up, 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 and let's check. Which of these functions is shooting up, up, up as x goes to the right? Definitely B. As x goes to the right, that's shooting up, up, up. The other one is just horizontal. A is horizontal, and C is just shooting down. So B is what 1 matches to. So let's draw a matching line here. Okay, now how about number 2? So number 2 says f of x approaches negative 2 as x approaches infinity. So again, as x goes to the right, as x approaches infinity, we want the function to be approaching negative 2. So it should look kind of flat, kind of horizontal along the line y equals negative 2 as we go to the right. And which of these satisfies that? Hey, look at this. Y equals negative 2, and the function is, as x goes to the right, it's very horizontal. It's just going along the line y equals negative 2. So yeah, that looks like what we want. And yeah, the other one doesn't have that property because it's just going down, down, down. This is the only one that matches up. So there we go. Okay, last one, number 3. I know it's pretty obvious which one that is now, but let's just go through it. So f of x goes to negative infinity as x goes to infinity. So as x goes to the right, we expect that f of x should be going down, down, down. So C indeed has that property. As x goes to the right, f of x is going down, down, down. It is increasing a bit beforehand, but that's not what matters. What matters is that the end behavior, as x goes further and further to the right, what's the general behavior? What happens? Well, initially it's increasing, but then overall it's just going down, down, down. So yeah, so that's what we're interested in, C. Great. Here's another example, and it's pretty similar to the previous one. Again, we're matching end behavior statements with the appropriate plot, and our plots are actually the same as last time, the exact same functions, but now our end behavior statements are a little bit different. The main difference is that now x is approaching negative infinity instead of positive infinity. So now instead of x getting bigger and bigger and bigger towards the right, in the positive direction, x is getting more and more negative towards the left. So we're going to be looking as x goes to the left in each one of these functions. Okay, so let's just go down the line. Starting with condition number 1, this end behavior statement says f of x approaches infinity as x approaches negative infinity. So as we go to the left, as x gets more and more negative, f of x should be shooting up towards positive infinity. And let's see which graph has that property. So hey, look, as we go towards the left in x, f of x is indeed shooting up. So that looks like a match. Great. Now b, on the other hand, that's shooting down, and c looks like it's leveling off. So yeah, definitely not either of these for this end behavior statement. Okay, now let's look at the next one. F of x approaches 1 as x goes to negative infinity. So as x gets more and more negative to the left, f of x should be leveling off to the value of 1. And which of these two has that property? Well, b just shoots down, but c, indeed, that does level off to the value of 1. So we match statement 2 up with graph C. And the last one, again, this is obvious, you can tell what it is now, but let's go through it. F of x goes to negative infinity as x goes to negative infinity. So as x is going to negative infinity, as x is going to the left, we want f of x to be going down, decreasing without bound towards negative infinity. And indeed b, as x is going to the left, overall it is going down. If we continue, it keeps going down. So that makes sense. Graph B with end behavior 3. Here's our last example. So we want to write the end behavior for each function plotted below for both x goes to positive infinity and x goes to negative infinity where possible. It might not be possible to write end behavior for all of the functions, but we'll give it a shot and see the best we can do. So this time we have to come up with the end behavior statements. So let's write down our templates. For f of x, we want to know f of x approaches what as x approaches positive infinity, and the same idea for x approaches negative infinity also. So let's write down that template. F of x approaches what as x approaches negative infinity. Now let's look at positive infinity first. As x approaches positive infinity, x is getting more and more positive towards the right, what is f of x doing? Well, it looks like f of x is leveling off, and it's leveling off to the value of 2. Y equals 2, that's the horizontal asymptote here, getting closer and closer to that value as x increases, so that is our end behavior. F of x approaches 2 as x approaches infinity. And now how about as x approaches negative infinity? Well, as we go left towards negative infinity, as x decreases towards negative infinity, the function is shooting up but leveling off again at y equals 2. So again, it's just approaching 2 from as we go to negative infinity also. It's the same end behavior, approaching 2. One thing to point out before we go on is that there was a vertical asymptote here, like the function is blowing up to infinity as x approaches 0, and it's going down to negative infinity as x approaches 0. But when we're talking about end behavior, that's as x approaches infinity and as x approaches negative infinity. It really doesn't matter what the function is doing kind of in the middle. All that matters is what's happening at the ends. So you can kind of like cover up the middle, and you can just look at the ends. You see it's going to 2 from both directions. Okay, now let's look at g of x. So we'll write down the same templates. We want to find g of x goes to what as x goes to positive infinity, and likewise g of x goes to what as x goes to negative infinity. Let's deal with positive infinity first. So as x is going to the right towards positive infinity, what is g of x doing? Is it going towards anything? Well, g of x is oscillating up and down, so that doesn't look like it bodes well for end behavior, but you'll notice that the oscillations are decreasing. So it's actually leveling off. The oscillations are getting smaller and smaller, and if we continue on and on and on, it looks like it's continuing to get closer and closer to the x-axis. So the x-axis is just the y-coordinate of 0. So g of x is really approaching 0 as x goes to positive infinity. So that's our end behavior. G of x approaches 0 as x goes to positive infinity. And now as x goes to negative infinity, let's go the reverse direction, going to the left. G of x is oscillating up and down and up and down and up and down. And is it settling down to anything? Is it leveling off? Well, no. It's blowing up in both directions. But we can't say for sure it's going to positive infinity because it's also blowing up in the negative direction. We can't say for sure it's going to negative infinity because it's also blowing up to the positive direction. It's not going to any one spot in particular. The range just keeps getting bigger and bigger, so it really just doesn't have any end behavior as we go to the left. So we can't write any good statement for that. It doesn't go to any particular value as x goes to negative infinity. Okay, so now let's take care of the last one. H of x, write down our template. H of x goes to what as x goes to infinity, and also h of x goes to what as x goes to negative infinity. Okay, so looking at this again, remember all that matters is what happens at the ends of the function. So this in between the function, you can kind of just like cover up, and it doesn't really matter. All that matters is what's happening at the end. So as x goes to positive infinity, at the end of the function, it's going down, down, down this way. So h of x is really approaching negative infinity. And as x goes to negative infinity, as x goes to the left, h of x is going up, up, up this way. So h of x is approaching positive infinity. Now we're developing some vocabulary that we can use to talk about functions even when they look very complicated. And in the future, we'll continue to develop these ideas about the general behavior of functions so that we can talk about general behavior even for very complicated functions.